Okay, so when we're measuring bacterial growth, what we're using is optical density, which is a measurement of how cloudy a culture has become. Okay, so this is a proxy for the number of cells that you've got. But we might also want to be able to predict how many cells we actually have in a culture based on an optical density measurement. So what we're going to do to achieve that is we're going to make what's called a standard curve. All right, so with a standard curve, what we're going to do is we're going to have a culture, and we're going to dilute it several times. We're going to measure the optical density for each one of those dilutions, and we're also going to plate them to see how many cells per milliliter are in each one of those diluted solutions. We're going to plot that this way. So we'll have our optical density on the x-axis. We're going to have our actual measurements of colony-forming units per milliliter on the y-axis. So hopefully what we'll see is that there's a nice line, right? That the higher the optical density, the higher the colony-forming units per milliliter that we actually measure, right? So if we wanted to convert from an optical density measurement, which is really easy to get, to the much more difficult to measure CFUs per mil, we can use what's called a standard curve. So we take these measurements, and we're going to do what's called a linear regression. We're going to find the best fit line that goes through it. When we do that, we'll have the slope of the line, the intercept, right? And that's really all we need to be able to convert any optical density measurement to a CFU per milliliter measurement. So I'm going to show you how to do that with a spreadsheet in a second. Okay, so here we have measurements of optical density and corresponding CFU per milliliter values obtained by plating the different dilutions. So what we're going to do is we're just going to plot this real quick as a scatter plot just to see what it looks like, right? So yeah, I'm going to use just a regular XY scatter plot, no lines. And you see where we do this, I mean, these points line up pretty believably into a straight line, right? So it looks like the experiment worked. Okay, so the next thing we want to do is we want to calculate the linear regression. So to do this, I have to select a 2x3 grid and type in this formula, lin-est. All right, the first thing I want to do is select my y values. This is the thing we want to predict, right? So here's going to be CFU per milliliter. And then I'm going to hit a comma and then select the corresponding x values. Okay? And then I have to put in comma 1 for reasons that I don't want to explain. And then I'm going to hit Control, Shift, and Enter. And that's going to enter this formula into all 6 of these cells. And we're going to get different information from each one of the cells. All right. So first of all, these numbers are really super big. So I'm going to change them to scientific notation to make it a little easier for us to understand them. There we go. All right. Cool. So let's see what we've got here. So the first thing we have, this is the most important thing, is the slope of the line. And that's just the top left value here, so around 4 times 10 to the 9th. All right. Then we have the intercept as well. Of course, that's this top right value. Right? So we have both of those, and we can calculate any unknown value. We also have a value called the r-squared value, which is the bottom left value here. And the closer that is to 1, the better fit the line is to the data. Right? So when it's really low, it means the data is noisy, and we can't be that confident of the line. But here it's pretty good. It's about 0.97. All right, so let's do a problem now. Let's say that we have this standard curve, and then we measure an optical density of 0.36 for a culture. So how many CFUs per mil does that culture have? We just take 0.36, multiply it by the slope, and then add the intercept, right? Y equals mx plus b. And that gives us this value of about 1.2 times 10 to the 9th CFUs per milliliter. And that's how we use a standard curve.